Welcome. My name is Subhasish Chatterjee. I am an assistant professor in the Department of Chemistry and Physics. My research interests involved biophysical chemistry and nanoscience, focusing on the structural and dynamical properties of biologically inspired materials and supramolecular systems. My research group applies experimental and computational techniques to investigate the physiochemical properties of bioinspired systems. Molecular self-assembly and cooperative assembly are critical in developing complex materials associated with many biological functions such as structural coloration, photosynthesis, and microbial virulence. Molecular building blocks self-organize to form supramolecular materials with a diverse range of functions, and we investigate the nanoscale properties of these materials that also promote a great deal of technological applications. Broadly speaking, natural materials fall into two categories: a group of macromolecules such as nucleic acids and proteins that maintain a relatively long range structural order. Another group belonging to chemically heterogeneous systems such as plant cuticles and melanin pigments is structurally disordered but carries out many important functions in biological system, many essential functions in biological systems. Molecular self-assembly and co-assembly can generate supramolecular materials responsible for structural coloration, photosynthesis, and microbial virulence. My research group is currently investigating peptide-based materials, photosynthetic protomolecules, and melanin pigments. These chemically heterogeneous materials have augmented cross-disciplinary research interests in decoding nature-inspired materials design. Notably, molecular assembly techniques can generate unique nanomaterials such as carbon-based quantum dots and biosynthetic disordered pigments. Correspondingly, our work aims to decipher the structural characteristics of biochemically diverse systems, linking their supramolecular architecture with material properties. The interdisciplinary research theme, driven by synergistic experimental and computational studies, focuses on the fundamental structural and dynamical properties of bioinspired soft materials at the molecular and nanoscale levels, underpinning the connection between molecular biophysics, structural biology, and system chemistry as an emerging field of bioinspired materials with potential applications in biotechnology and nanoscience. The ongoing work involves chemically heterogeneous biosynthetic and organic material systems with an elusive structural design. The experimental components delve into deducing their molecular frameworks by applying spectroscopic techniques, whereas complementary studies involve computational modeling, molecular dynamics, and density functional theory applications. While working in this emerging research area, our student researchers in the group apply analytical and biophysical experimental techniques, computer simulation, and biomaterials synthesis strategies. And I am very thankful to my students who are now part of the groups. Thank you so much for your attention, and I would be happy to answer any questions. So please feel free to email me or stop by my office. Thank you so much. Thanks again.